Hello, my name is Jack Saltzman, and I will be going over the final lab for Physics 1, which is the Slinky. So to introduce the lab, the purpose is to analyze the motion of the bottom of a dropped Slinky compared to the glow script model. The principles used are Newton's second law and drag force. The system is the Slinky, and then the source is the Earth in the air. And to preview the results, the bottom of this Slinky did remain stationary. So to the right, we have the fundamental physics principles. So for the experiment, quote unquote, because it was really just a video provided, it showed a drop Slinky, which you could see there's two guys, and the guy on the left was a reference for scale of the experiment. So we measured his height, and the data from the tracker video was put in a spreadsheet to be used for the lab. And possible sources of error could be incorrect tracking or human error in the video. So for the assumptions and initial conditions, we have to create the visualization, which means the spring or the Slinky and the trail and then the graph. The initial conditions are the mass of the Slinky was set to be 0.218 kilograms. Obviously, we have the gravity constant. We have the initial position of velocity from the tracker data, and then the time starts at 0 and is updated by 0.033 seconds. We have the j hat, which is in the y direction, and then the drag coefficient, which is pretty large. So we have two while loops, one with gravity and one with drag force. And for both of them, we basically just update the net force, which to the left is the tension, essentially just the tension plus the gravity. And then to the right, it's the tension plus the drag force. And then we have to update the velocity in the position, and then we have to plot it. So observations, this is both graphs plotted on the same Excel plot, and they both match up very well. There's some slight fluctuations in the tracker data, which could be a result of the error mentioned earlier. The x-axis is time, and then the y-axis is the y position of the Slinky. And then you could see it's sort of level because the bottom is stationary, and then it goes down. It's in a linear fashion. So why does the bottom stay still? The drag force in the positive y direction and the force of gravity in the negative y direction cancel out. The drag force can also be thought of the force of tension within the Slinky. And the Slinky loses its tension as the time goes on, and the force of gravity eventually becomes larger than tension, causing the Slinky to fall. So if this experiment was done on the moon, the force of gravity being smaller would make the Slinky stretch significantly less, and the less stretch would mean the bottom wouldn't be stationary for as long. To conclude, the Slinky being dropped doesn't mean only gravity is acting on it. It also has tension from itself. And this can cause the bottom to be stationary. Tension can be found in many instances. So normally in class, we do it with a rope or maybe even a spring. But it could be also in something like a Slinky being dropped. It could be in many different things you see in daily life. And then the different gravity constants will change the results of the experiment. If you're still watching, thank you so much for watching and listening to this boring lab. It's the last one of the semester, so, we're free from labs. Thanks. Have a good one.